You are welcome to the Scholar online class. I will be your mathematics teacher for today, and my name is Mr. Abdulwasi. And our topic for today is on trigonometric ratio or trigonometry. So under this, we'll be looking at trigonometric ratio, we'll be looking at inverse of trig ratios, proof of sine squared theta plus cos squared theta is equals to 1. We'll also look at complementary angles, special angles such as 0 degrees, 30 degrees, 60 degrees, 45 and 90 degrees, then the application of the trig ratios. Now, to start with, when you talk about trigonometry, it's an aspect of mathematics, just like you know that mathematics is very, very broad. It's just like what the house, where you have other parts. So trigonometry is an aspect of mathematics that deals with what? With the study of triangle with respect to what? To the sides. Now, let's take, for example, we have the triangle, a right angle triangle. This form. A, B, C. This is a right angle triangle. Right angle at what? At B. And that box there stands for what? 90 degrees. So when you have a triangle like this, it has three sides. The longest side is the line AC, which we only call the hypotenuse. While the other two sides in mathematics, we call it what? Adjacent sides, provided there's no angle there. So I call this adjacent side. This is also what? Adjacent side. It is only when I now put an angle that you now talk about the other ratio. So from what we have here, this is the concept of trigonometry. So looking at the first aspect, we are talking about trigonometric ratios. When you talk about trigonometric ratio, it simply means what? Three ratios, three basic ratios, which are what? Sine, cosine, and tangent. So for our trigonometric ratio, here we are talking about what? Sine, cosine, and tangent. So we abbreviate these three with the word, the three initial. That is, our sine we abbreviate as what? SIN. Our cosine as what? COS. And our tangent as what? TAN. So that is sine, cosine, and tangent. And these three ratios are summarized in a particular context. But before we go to that, let's look at this triangle now to look at the trig ratio that we are talking about. Assuming I'm giving triangle ABC, right angle at B, and I'm provided with an angle C as what? As theta. The theta stands for what? The angle. Then in this case now, the longest side is always the hypotenuse. So this AC still remain the hypotenuse, which we also use the word, the first three initials, HPY. Then where the angle is facing directly, if you look at this angle now, starting at this position, where this angle is facing directly, this is where it's facing directly. Why the angle is resting on this line. So where the angle is resting is called the adjacent. And it is constant. Wherever the angle is resting is called the adjacent. Where the angle is facing directly is called the opposite. So it means that we have labeled the side of the triangle completely. The side are what? We have three sides. Side AB as the opposite, side BC as the adjacent, and side AC as well, the hypotenuse. So with these three now, these three also can be abbreviated as our hypotenuse using the first three letters HYP, because that's what I'll be using subsequently. Our opposites using the first three letters OPP, and our adjacent using the first three letters ADJ. So this is what I'll be using subsequently. So from what we have here now, then we can now identify what we mean by sine, what we mean by cosine, and what we mean by tangent by definition, because all these three have what? Ratio. And when you say ratio, it means you have numerator as well as what? Denominator. Now starting with the first one, I need sine theta. Sine theta. So before we can label our sine theta, there's an acronym that what? That summarize these three. And that is what we call SO. Ka. Twa. This is an acronym. The first letter here stands for the ratios. S stands for what? Sine. Meaning what? Opposite divided by what? Hypotenuse. Ca stand for what? Cosine, meaning adjacent divided by hypotenuse. And toi, T stand for what? Tangent is equal to what? Opposite over hypotenuse. So I want to look at these three ratios. So it means that my sine theta, SI theta, this is how you write it, from this diagram, based on the definition, we say it's what? Opposite all over what? Hypotenuse. That means sine theta is what? AB divided by what? Side AC. So if I call this side C that as small letter C, and my A as small letter A, and my B as what? Small letter B. That is, where the side, the angle is the capital letter, the side opposite is the small letter. The angle is the capital letter, the side opposite is small letter. The angle is the capital letter, the side opposite is small letter. So we can also use that in this context. So it means that sine theta, which is what? AB over BC. Using the value that we have there, our AB is what? Small letter C. And our AC is what? Small letter B. That defines the first ratio. That is, sine theta is equals to opposite over hypotenuse. That is small letter C over small letter B. I hope that is taken. Now let's go to the second one. Cos theta, COS, then theta. By definition, ca, adjacent over hypotenuse. So let's go back to the diagram again. Where is our adjacent? This is it here. Which is what? BC. Divided by hypotenuse. That's AC. Now using the small letter, our side BC is what? Small letter A. And our side AC is what? Small letter B. That defines the second ratio. That is, cosine is equal to what? A over B. Then the third ratio, tan theta. Going to this, toi means what? Opposite over hypotenuse. Going back to the diagram, our opposite is what? AB. AB. And our hypotenuse is what? AC. And opposite over adjacent, our adjacent is what? BC. Now using the letters, small letters there, that is small letter C divided by small letter A. So that defines the three trig ratios, which we call so basic trig ratios. Sine, cosine, and tangent are referred to as what? Basic trig ratios. And that defines as B over C, C over B for sine theta, A over B for cos theta, and A over C for tan theta. Let's take an example before I move to the next stage. Assume you are given a triangle in this context also. Now I want to vary the angle now. Let's say the angle theta is placed here now. This is side A, side B, side C. Are you with me? Or let me even change later. This is PQR. This is PQR. The angle is stationed here. Let's say this is 4, this is 2, and this is 10 by length. And we are asked to find these three ratios. Following the same so-called, then I can define my sine theta from this diagram. You look at the angle now, it's placed at what? P. And since it's placed at P now, where is that angle theta facing? It's facing what? The number down, which is what? Line QR, which is what? The 2. So it means that the position of the opposite has what? Has been altered compared to the first diagram. So what you look out for in any right angle triangle is what? Where the angle is positioned. That will determine where the opposite will be. So from here now, our opposite will be what? This side here, which is QR. Our adjacent will be where the angle is resting on, which is this side. And our hypotenuse is what? Always the longest side. So our hypotenuse is still remains what? The 10. So from what we have here now, then we can define the three ratios. So my sine theta is equal to what? Opposite, that is QR, all over hypotenuse, that is PR. I repeat again, sine theta is equal to opposite QR over hypotenuse, that's what? PR. So using the number, our QR is what? 2. And our PR is what? 10. So going by that, we can reduce it to the lowest fraction, that is 1 over 5. That is the answer. I hope that is clear. Let's take the second one. Also, cos theta, which is what? Adjacent over hypotenuse. So let's go to the diagram. Our adjacent is what? PQ. All over the hypotenuse over is what? PR. So if you input the number, our PQ is what? 4. And our PR is what? 10. We can also reduce this to the lowest fraction. 2 in 4, 2. 2 in 10, 5. That gives us 2 over 5. That's the second ratio. Likewise, our tan theta, which is defined as what? Opposite all over hypotenuse. Let's go back to our diagram. Our opposite is what? QR. Divided by the hypotenuse is what? Adjacent is what? PQ. So going by that, our number for the opposite, which is what? 2. And our adjacent is what? 4. Reducing to the lowest ratio, that's 1 over 2. So that defines the first aspect, which is what? Trig ratios of what? Simple angle, which is sine, cosine, and tangent. I hope that is clear. Now let's now move to the next stage. But before we move to the next stage, there's a relationship between tan theta, cos theta, and sine theta. And what is the relationship? Let me define it here quickly. The three are related by definition. We have tan theta is equals to sine theta divided by cos theta. This is the relationship between the three. And we are going to prove that quickly. So let's see if that is true. Remember, we still have this, so I'm not going to tamper with this. Let's see if that definition for tan theta to be that. Now, still using this first diagram here that I have here, the second diagram. This is my A, this is my C, this is my B. Remember, I said our tan theta is defined as sine theta all over cos theta. Let's see if that is true. Now, from what we have here, our tan theta is this. Let's use the ratio that we've gotten. Now, I have tan theta is equal to sine theta is what? C all over B, right? Cos theta is what? A over B. That's division. Let's use this sign. Divided by what? A over B. So that means my half tan theta is equal to C over B times by law of reciprocal. When you change division sign to multiplication sign, the denominator will go up and the numerator will come down. That means I have what? B over A. If you look at this very well, something will cancel out. And what is fizzling out there is what? The B. So therefore, tan theta is equal to C over A. And look at the initial proof, which is also what? C over A. So that proves that what? Tan theta is equal to sine theta over cos theta. I hope that is clear. In class, we look at the various ways in which you can use this word to solve problem. Thank you.